Hello everyone, let's talk about another medium problem on Leetcode today, hands of straights. In this, Alice has some number of cards and she wants to rearrange the cards into groups so that each group size consists of group size consecutive cards. Given an integer hand where hand I is the value written on ith card and an integer group size, return true if she can arrange the cards, otherwise return false. So then they have given some examples as well. In example 1, we can see that Alice has cards 1, 2, 3, 6, 2, 3, 4, 7, 8, and then we can arrange them in the group size of 3, which is like 1, 2, 3, 2, 3, 4, and 6, 7, 8. So note that first of all that the group size that we create of each card is of size 3, and second thing is like all of them are in order and they are consecutive. So it is like 1, 2, 3, or if it starts with 2, then other cards will be 2, 3, 4. Similarly, if it starts with 6 and then 6, 7, 8. So that's how we get the hands of straights. Now let's jump into the solution space. So first observation we can make is that hand size should be multiple of group size. So for example, in this case, we have 9 elements or 9 cards in the hand and group size was 3. So that's why we were able to form 3 groups. If it was 6, then we would have formed 2 groups. So this will help us in validation. Another thing to note is that card can occur multiple times. So for example, 2 occurs here as well as here. Then it becomes a part of the solution here. Like it will be part of 1, 2, 3. And here it will be part of 2, 3, 4 group, right? Similarly, 3 was part of 1, 2, 3, and then it's also part of 2, 3, 4. That means we need to have some kind of a count. If we have used the card, we can't reuse it, but if we have a duplicate, then we can actually use it in another group. And one more thing to note is that keeping the cards in order can help us. So for example, suppose the cards are 1, 2, 3, and group size is also 3. Then when I pick up the card 1, I will have to look for card 2 and 3 as well, right? Because those are the 3 consecutive numbers. But if the array is not sorted, then I will have to search around throughout the array. So sorting will also help us. Now let's see how we can apply the sorting as well as counting the frequency together. Let's take hands array and group size equal to 3 from example 1. Now we sort these cards such that now we have the cards 1, 2, 3, 4, 6, 7, 8, right? These were the cards present for us. And then we create a stack of these cards such that all the cards with the same number are in same stack. So for example, all the 2s are together, all the 3s are together. And in terms of data structure, we can build a frequency map. So we can see that actually 1 occurs once, 2 occurs twice, 3 also occur twice, and then rest of the cards also occur only once. That's how now the cards look like to us. So now our idea is simple. We will pick up the minimum card from the list. In our example, it will be 1. Then because our group size is 3, we will try to find another 2 cards which are consecutive and that can form the group. So for card 1, it will be 2 and 3. So we will just pick up 1, 2, 3 and form one group. Let's call it like a green group or something. Note that I have marked all the unprocessed cards with orange color. That means we still need to process card number 2, 3, 4, 6, 7, 8. Now we update the count array. 1 is fully exhausted, so count for it becomes 0. But we still have card numbers 2, 3, 4, 6, 7, 8 with 1 count each. Then we pick up the next smallest element present in the cards, that is 2, right? Then we see are remaining 2 consecutive elements present in the cards or not, that is 3 and 4, and answer will be yes, right? Because we had 1, 3 and 1, 4 remaining, so we just pick them up. Let's call them pink card group or something, but we are still not done. So we still have 6, 7, 8 remaining. Now we see what next minimum element we can pick from the stack. So we can see that 3 and 4 are already done, but now we have 6, 7, 8 as the cards remaining with each quantity being 1. Now what we can do is we can just pick up 6 and then again look for another 2 cards because our group size or window size is actually 3. So we will see if 7 and 8 also exist in the group, and we can see that actually they are present. So let's make a violet group out of them. And now all the cards are done. We can see it because our counts are all 0. So that means we have reached the end of the algorithm. We were able to form all the groups. There was no case where we couldn't form any group or anything. So we will return true in this case. Also, at any point, if we couldn't make a group after picking up the minimum element, we will return false. Now, what data structure we can use to make this algorithm work? So we noticed 2 things. One thing is we required like sorting, right? Because our array was sorted. And second thing we required was some kind of a frequency map. So In Java, which data structure can actually help us here? It is tree map, because the keys in tree map are sorted based on the comparator we provide. And it also is map, right? So we can actually also create a frequency map based on it. Adding the value to the tree map takes log of n time. So when we are adding n elements, it will take n log n. Also, when we are fetching the elements from the tree map, it will take log of n time. But in Java, a normal hash map takes O of 1 time. So there is some trade-off here. So this is one approach. But now notice one thing, do we really need array to be sorted or the data structure to be sorted? And answer is no, because we are always picking up the minimum and then finding the next consecutive elements. And that can be actually automatically coming from the lookup into the hash map, for example. So what we can really do is like we can actually use a min heap. And in Java, we actually implemented using priority queue. And then building the min heap takes O of n time, right? Where n are the number of elements that we add to it. And then what we can do is we can pick up always the minimum element from the min heap, look up the frequency of it in the hash map, because we have to build the both frequency map and the min heap together, and update the frequencies as soon as we use them to form our group. Finding the minimum element in the min heap again takes log of n time, right? And in this case, this will take like n log n time for us, because we will be removing n elements from the min heap and then processing them. It depends whichever approach you prefer. In my blog, actually, I've provided the solution to both of them, but I will be actually coding priority queue plus hash map solution. Now let's jump into the code. Now, first thing we will check is if hand size is multiple of group size or not. If not, we will return false, because we have to form those many groups in the hand. Because modulo operator does not return 0, that means it's not a multiple, so we will return false here. Now, next thing we will do is we will create a frequency map where we will track the count of all the cards. So we will loop over the hand and create the frequency map based on it. In Java, we can use get or default to get the default value if the key does not exist. So we will get default value as 0. And if it exists, we will add 1 to it. So this is how we will create the frequency map. Now we will create the min heap in Java, and the way to do is using priority queue. That will be coming from the keys of the card counts, because it will contain all the unique card values, right? So now we have the list of card ready in the min heap, technically in a non-sorted way, but still we will always get the minimum card value that is guaranteed. Now we will run the loop till we actually get the heap as empty, or till we have processed all the cards, or we find that, okay, we cannot form the group. Then in that case, we will return false, but we will see how. So we get the minimum element from the queue using min heap.poll. Current card count will be card counts.get card, right? Because it's a frequency map. And if count was already less than equal to 0, we will continue, because that card has already been processed. We have found this card, which is a minimum. If it doesn't exist in the frequency map, that means we don't have these cards remaining anymore. So we don't have to process it anymore. But if we have one of these cards, that means now we have to find next group size -1 consecutive cards. So for us, next card will be current card plus I. So initially I equal to 1, but then it has to go till group size. If map does not contain the next card, or card counts is less than the count of the original card, because suppose if 1 was the minimum card and it occurred twice, then 2 also should also occur twice. Similarly, 3 should also occur twice if the group size is 3. If it's less than 2, that means we can only form one group, but we will still have one remaining. And then next time when we come, we will not actually find 2 in the set, because we had only 1, 2, which actually we used with the previous one. So I hope this makes sense to you. And once we reach in such situation, we should return false. Otherwise, we should just update the frequency map. So that's it. And now we have reached the end of the loop. So we can just return true. And now let's try to run this code. There's a missing return statement. Because I was returning at the wrong place. Maybe I should do it here. Yeah, awesome. Now let's submit this code. Cool, it was pretty fast, beats 56%. And in terms of time complexity, you can see that when we create this frequency map, it takes O of n time. Then building this min heap also takes O of n time until the min heap is empty. That means it has, in the worst case, it will have n elements. And then removing those elements take log of n time. So overall time complexity will be n log n. I hope this video was useful to you. If it was, please like and subscribe, and also comment below which part you liked and which you didn't, and what video should I work on next. Thanks again. Have a nice time.